はい、皆さん、こんにちは。お時間となりましたので、これからちょっと始めていきたいと思うんですけど、ちょっと時間になったばかりというところで、少し待ちながら、ちょっと開始できたらなと思っています。すいません。ちょっと開始時間が若干遅れるかもしれないんですけれど、よろしくお願いします。で、最初になんですけれど、ちょっと今回、ちょっと初めての試みというところで、同時通訳というのを使ってやっていこうと思っており、初めてというか、何回かいろんなイベントやってるんですが、今回のこういう一連のイベントでは初めての試みで、同時通訳というものを使っていこうかなと思っています。こちらの画面に書いてあるように、この Zoom の、もし皆様がZoom の最新版を、デスクトップをインストールしていただいている状態であれば、その下の方に、通訳というボタンがありまして、そこからその好きな言語を選択して、おくことができますと。で、そこの英語、日本語という好きな言語を選んでいただくとともに、そのオリジナルの音声をミュートするっていうのを選んでいただくと、その同時通訳、好きな言語で常に聞き続けられるような設定になっております。なので、この設定をしながらちょっとお待ちしていただけるとありがたいかなと思います。もしなんかその設定等で困ったことがありましたら、そのチャットで、はい、書いていただけるとありがたいかなと思います。So today's event, we will use the Japanese English simul translation in this event. And if you would like to listen to the same interpretation, please use the interpretation button at the bottom right of the screen and select your preferred language and mute original audio. ちょっと初めての試みというところであれなんですけど、よろしくお願い、設定の準備をよろしくお願いします。はい。で、そうですね、皆さん、もし入ってきたばかりの方いらっしゃったら、こちらの画面に映っている、設定方法をお読みいただいて、その同時通訳で今回お送りしてしますので、もし通訳が必要な方であれば、英語、日本語っていうのを選択していただけると助かるかなと思います。そうすると、自分の聞きたい言語で聞けるようになってますので、よろしくお願いします。で、今回基本的にそのオープニングとクロージングは日本語で行うんですが、残りの実際の本題であるプレゼンテーション部分は英語、もで行われる予定です。よろしくお願いします。時間も経ってきて、ぼちぼち人も増えてきたというところで、早速始めていきたいなと思いますので、よろしくお願いします。で、オープニングですかね。本日はメルカリ ML&Search Talk にご参加いただきありがとうございます。このメルカリ ML&Search Talk と題した一連のイベントでは、ML エンジニアや、PM がメルカリで使われている技術やその応用について発表します。またその後、質疑応答で発表内容や皆様から事前にいただいた質問について深掘りしていきたいと思っていますので、よろしくお願いします。で、本日なんですが、ご覧のようなアジェンダでお送りできればと思っています。ちょっと時間に関しては多少ずれはあると思うんですが、よろしくお願いします。特にこの第2回では、カスタマーアンダースタンディング、お客様理解と題しまして、マーケティングやお問い合わせ対応で、どのように ML を、活用しているかというのをメインテーマで紹介させていただきます。最初の2つは特にそのマーケティングやクーポン施策、どういうクーポンを配るかということに関わる話です。で、3つ目に関しては問い合わせ対応に関わる話です。ご覧のようなスケジュールで始めますのでよろしくお願いします。 で、ですね、次。で、次にこのイベントのご案内になりますが、まず本イベントは録画させていただきますと、後日アーカイブ配信、YouTube 等でアーカイブ配信する予定です。もし途中で用事があって抜けられる方も後で見られますのでご安心ください。また、当イベントなんですけど、Twitter ハッシュタグとしてメルカリ_AI っていうのを使っておりますと、ぜひぜひ、気軽になんか話す内容とか公開しても大丈夫だと思うので、そういった内容というのを、Twitter とかに投稿していただけるとありがたいなと思っています。また、本イベントはカジュアルな感じで、気軽に参加していただければと思っていますので、食べながら、飲みながらお聞きいただいて構いませんので、ぜひリラックスして参加いただければと思っています。よろしくお願いします。で、この Zoom のチャット機能なんですけれど、この皆さん見ている画面だともしかしたら上か下かとかに選べるボタンがあって、チャットだとか Q&A の機能があると思います。それぜひご利用いただいて、チャット等で、コメントとか感想を書いてもらうのもいいですし、その Q&A で、発表途中であっても、適宜気になったことというのを、英語、日本語、関係なく自分の好きな言語で、投稿していただければと思っております。よろしくお願いします。で、早速なんですけれど、ちょっとなんていうんですかね、こういったチャット、見知らない人はチャットがあるところに、見知らない人がいるところのチャットに、投稿しにくいかと思いまして、ちょっとその、アイスブレイキング的に皆さんの好きな食べ物とかをここに書いていただけるといいかなと思います。皆さん好きな、ランゲージを使って、言葉を使って、投稿していただけるとありがたいです。そうですね。僕は何ですかね。僕だったら何を書くかっていうと、そうですね。寿司とか書いちゃうかもしれないですか。寿司。そうですね。寿司とか書いちゃうかもしれないですか。そんな感じで、はい。焼肉とか餃子とか、はい。そうですね。ちょっとお腹空いてきましたね。僕まだご飯食べてなくって、ちょっと質問ミスっちゃったかもしれないですね。もうお腹空いてきちゃいましたね。はい。だから皆さんは、僕は食べないんですけど、皆さんは好きなものを食べていただいたり、飲んでいただいたりすればいいかなと思っています。よろしくお願いします。はい。で、次はです。Q&A タイムは、ちょっと別の時間で、違うか、別のボタンで Q&A できるので、そこも後で質問があれば使ってみてください。これから、早速プレゼンテーション始まっていくと思うんですけど、適宜、Q&A していただけると、プレゼンテーションの後だとか、もしくは最後にまとめて Q&A として拾えると思うので、ぜひ質問してください。はい。では、そんな感じです。で、早速、一つ目の話題からいきたいと思います。レナさん、ちょっとよろしくお願いします。Could you share your screen and start your presentation, Renat?
Yeah, just give me a second.
Thank you.
Okay, the screen, you can see the screen?
Yes.
Okay, great. So yeah, let's get started. Hello, everyone. Thank you for joining. Thank you for taking the time. My name is Leonard. I'm a product manager here at Mercari. And today I want to talk about how we at the data science team, we work with a lot with marketing and how we try to increase customer engagement using different marketing campaigns. Just to give you some background why I'm talking here today. So I actually started my career at a company called Tableau, actually here in Japan as well. So I was working as a product consultant for them, and Tableau is a product for data analytics. Maybe a lot of people know you actually. And there I got into this world of data and got really excited about using data to improve business, improve products. Later, I wanted to do something closer to the product, so I changed to Rakuten AdRoll, where we made custom marketing solutions for Rakuten using Rakuten's customer data, user data, and the technology from this company called AdRoll. a lot changed in the organization structure, and this was a joint venture, which actually doesn't exist now anymore. So just last year, I changed to Mercari as a product manager. Again, working on similar products, again, really close to marketing and between, with the data science team to make smart solutions for our customers. And that's exactly what I actually want to talk about today, right? So really simple. I'm just going to go over two main parts. First one, we're going to talk about a marketing funnel or framework called R. They're going to generally talk about how we at Mercari measure actually marketing, and then also some of our projects. And after that, I want to talk about a couple of use cases, like real examples that we did last quarter, something that we're actually working on right now, to give you an idea of what kind of challenges, what kind of products we are working on. And you can see the whole idea is not to really go into details. I'm not going to talk about specific models we're using or statistics. First of all, I'm not the right person, I think. And we have also very smart people after me. So the next two sessions, we have actual scientists or the engineers. They're going to talk more about the nitty-gritty things. I just want to give it an overview about some of the products that we're working on. And I hope that maybe in the end that you feel inspired or maybe even excited about some of the stuff that we're working on. And if you're doing something similar, maybe you can, it will be some inspiration for you. Or if you are just interested, maybe you can also, we can stay in contact. You can always contact me on LinkedIn. I'm going to share that later as well. Or you want to work at Mercari, if it looks really interesting, we're always looking for people to hire. But basically just I want to share with you what we're working on. Feel free to use the Q&A feature as mentioned earlier. So even within the sessions, just ask questions. I probably only get to answer them in the end, but feel free to fire away there. Right, and then without further ado, let's get started with the first point. I wanted to talk about this marketing funnel or framework, which is known as R, or the pirate funnel, because it kind of sounds like the sound a pirate would make. And it's not something we invented or that's unique to Mercari. It's pretty common. I've seen it before in other companies, and it's kind of describes the different stages a customer goes through. And from the very top, of course, you have a lot more people or customers. And then when they go further down in the funnel, it will become less and less users. But the relationship to the company will become more and more engaged down in the funnel, basically, right? So what you want to do in marketing is, first of all, have as many people inside the funnel as possible. So have a lot of input on the top, and then increase the amount of people that go to the next stage down the funnel. So you have more and more people if possible. That's how the funnel in general works. But every company obviously uses it differently. So I wanted to go through each stage real quickly to explain what those funnel stages mean for us, and also how we measure or some examples of how we measure the success or users in those funnels. A very top awareness is pretty straightforward. So you can imagine in Japan, we have around 120 million people. If we just look at Japan, and not everyone knows about Mercari, right? I'm sure a lot of people do, but not everyone. And the first stage is just making sure people know about Mercari. They are aware of the product, aware of maybe what values we stand for, what this product does. You can think of typical marketing campaigns here as like broad stuff like TV commercials, right? Some traditional marketing methods, or maybe a YouTube clip, a YouTube advertisement, or a banner on top of a website, something that you show to a lot of people that is often attributed to awareness campaigns, right? And you would measure how many people have seen it, impressions, something like that. Then in the next stage, acquisition, this is where we in Mercari actually measure how many people registered, so made an account with Mercari. This is different from company to company. So a lot of companies actually just measure how many people visit a website, right? So maybe they see an ad and then they go to the website, and you would measure how many of a click-through rate you have there. For us, visiting is not as important. So we want to have customers make the first step as registering. So we look at number of new accounts per month, for example. That's something we would look at. Next stage, we have acquisition. This is mostly the first step of a desired action from our point of view. So this is where the customer experience the core value of Mercari, basically. So they either buy something and experience how it is buying and getting a probably used product, right? Having that experience, listing, right? And then hopefully also selling, and then paying is when they use MercaPay to buy something outside of the Mercari marketplace, right? When they do buy something in the convenience store or maybe an online shop or something like that. And we would actually look at these three things separately very often. So we would try to increase the conversion rate for buying, right, or for listing, etc. Sometimes we would also look at them combined. So we want to a very engaged customer, for example, is someone that does all the three things. So we may do want to incite customers to do all these three things in a certain period of time. There's activation, and then retention is basically repeated activation, right? You want them to repeatedly experience buying something, listing something, or paying with Mercari. This is where we create what's called customer lifetime value. So a customer, that we don't lose them right away after the first purchase, right? We want to make the product still interesting enough that they stick with us and keep using our product. That's the retention part. And finally, the holy grail is basically referral. This is when the engagement or the relationship between the customer and the brand is so strong that they feel that they can recommend Mercari to their peers, to their colleagues, their friends, their family, etc. So we could typically look at number of referrals, right? As you probably know, there's a referral feature in Mercari where both parties can get points. That's a typical way to incite referrals, and then also easy to measure how many referrals we got. So this is the funnel that we generally have. Again, it's not unique to Mercari, but so what do we do in the data science team? So there's this marketing data science team that I'm working in, and we mostly right now focus on activation and retention. So things that happen after the customer registers, and we want them, we do campaigns to motivate buying and then repeated buying behaviors, for example. We work very closely with marketing, obviously. They care a lot about the KPIs and the business impact. And then we also work with backend engineers, right? We have dedicated engineers that host, help us with hosting the models, and also sometimes front-end engineering if it comes to creating certain campaign pages, etc. Right? So that's the kind of an overview of this funnel and how we measure some things, the impact of our projects. And we basically have to make sure that any project we are working on is going to have impact on one of these axes, basically on one of these ways to measure. Otherwise, we'll probably not work on it, right? So we want to make sure that we have a business impact. yeah, so with this overview, I actually want to go into talking about a couple of use cases. I have 3 today. I hope time will allow to talk about all 3 of them. And yeah, let's start with the first one, predicting user churn. From a product perspective, usually we would want to start with the problem, right? We don't want to make a solution to a problem that doesn't exist. So we try to think about the problem first and then about possible ways to solve it. That will not always be machine learning or something really complicated. Sometimes it can be really simple things, rule-based or just using generally data science, what we would call data science. So yeah, we want to make sure that we focus on the problem first. And the problem in this use case right now was pretty obvious. I mean, some customers are going to stop using Mercari, in this case, buying. They're going to stop buying something on Mercari at some point, right? No relationship lasts forever, right? So what marketing usually does traditionally is they would segment customers pretty simple by a rule set. For example, hasn't bought in the past 60 days. They would define that as a churned customer, and then they have campaigns for this kind of customer segment, right? They maybe send them a coupon to try to get them back into Mercari and buy something again. That works to a certain extent, right? Obviously, but we were thinking that it's very difficult to re-engage a customer that's already inactive, right? You can maybe think about it yourself anecdotally, that if you already left the product and haven't been using it, haven't used it for a couple of months, it's really hard to get back into it, right? Your mind already moved on, you're already onto other things, right? So we were thinking maybe we can do something to just prevent churning in the first place. So maybe we can approach the customer before they haven't bought anything for 60 days, right? Maybe there's a way to kind of predict or see a pattern in their behavior that indicates that they're about to churn. So the goal here basically was to increase the conversion rate. So we always have a goal in mind, the one we want to achieve, like a KPI. And here it was CVR, conversion rate. Yeah, and we wanted to increase conversion rate for customers that we're targeting and predicting to churn. Let me talk about how, yeah, the approach we took first. So we were actually looking at the different stages or the different actions the customer takes, the user takes before he makes the purchase decision, before he buys something on from another user on Mercari, right? Really simple put. There's a lot more small steps in between, of course, but usually, obviously, they would visit the app first, then because they have some need, they want to buy a product, they're interested into something, and then they would search for that product, right? They would type in search keywords, and if they find an item that looks interesting, they go into the item details. So they click on the item, they maybe read the descriptions, and that's where the customer usually explores all the different options he has, right? Different products within Mercari, but also outside Mercari. He looks at maybe other platforms. And then finally, at some point, he makes the purchase decision. So at step 4, he buys the product. And step 5 is ultimately what we want to achieve, right? Is GMV is basically the value of the products bought or sold. And then we get a cut of it, right? We have a commission fee that is basically our revenue at Mercari. Yeah, so this is basically the circle that the customer goes through. And we were thinking if we can find a downward trend in one of the leading indicators, that would mean they will buy less or stop buying at some point, right? That's kind of a, yeah, an easy way to look and predict in a way, right, at the customer's churning. It wouldn't make sense to look at GMV and purchase because that's already too late, right? If you see a downward trend in purchasing, so let's say some users only buy a product once per month, right? If you see a downward trend there, it's already too late probably. So we ended up actually using those earlier stages. They were very, very interesting. And spoiler, the item views actually was one of the best indicators which we ended up using. So that's the approach, what we looked at. And yeah, the solution then was relatively straightforward, right? So we found the leading indicators that correlate with buying or churning well in the end then. And we use that indicator to trigger campaigns. So that's pretty much a rule set that would trigger a campaign. First, we did that just with coupons because it's one of the easier ways to test this. So we would have a basic A/B test set up, right, where we send the treatment group coupons. So after we segment them with that downward trend, we would send them coupons. And then in the control group, we don't send coupons. And we would look at how much the conversion rate increased. So you can see this graph is actually how the conversion rate increased. The orange line is the one that we treated with the coupon, and the gray line is the one that didn't get the coupon. I left the axis description out, obviously, but you can see it's a pretty obvious gap. And it was statistically significant. So that was kind of a success that this just a rule-based approach actually for the segmentation had a positive impact. We're actually now considering if we can make it even better by using machine learning and more features to predict it even better. But yeah, that's at this point we have this rule set for now. So yeah, this is the prediction one for user churn. Next off, I want to talk about coupon cost optimization. This is where, yeah, let's start with the product, the problem again. So marketing is sending out different coupons to customers, right? Some of them we just talked about, right? We tested that with coupons too, but there are a lot of different coupons they use. And with the coupons, they basically want to incite or make provoke an action. They want to make the customer buy something or list something, right? Maybe they get 10% off if they buy something. Maybe they get 10% point back if they buy something, etc. But we were thinking that this is inefficient or not really cost efficient because if you send coupons to random users, so they would often pick them randomly or some arbitrary segmentation, is that we're thinking within that 100% of users you send coupons to, maybe 50% of them would have already bought something even without the coupon, right? We would call that organic users, organic purchases. So we're kind of using budget, marketing budget that is supposed to be used only on users that not going to buy something, for example. So you're kind of wasting that budget. Also, even within the users that bought something with your coupons successfully, maybe you didn't need to give them 10%, maybe 5% would have been enough, etc. Right? So kind of thought maybe we can make it more cost efficient and use less budget on these coupons. And here our KPI or goal was to increase return on investment. What we did basically is try to customize or personalize actually the coupons on a user level. We did that first by actually just segmenting users into groups, and based on past coupon data, we would then predict the likelihood of a customer taking the desired action given a coupon. So if we give this customer a coupon, how likely is he going to take the action of buying, for example? That worked pretty well actually for ROI. So we would then take that information and couple it with budget constraints. So let's say we only have 10,000 yen to use for coupons. Then we will look and find the customers that are most likely to buy something with the coupon. And maybe buy something with a higher value, right? And then we would give them coupons and use, in the end, we actually use something called mathematical optimization, but I don't want to go into details at this point. And as a result, we could increase successfully the ROI, return on investment, and also keep the conversion rate. So that's also very important. You can always cut cost somehow, right? But then you would also reduce conversion rate. But we were able to find a balance and increase the ROI while keeping a stable conversion rate. This is still something we are actively working on. So we did that a lot of research in the last quarter and had these successful results. And yeah, we are looking into other areas to put that kind of optimization into use. Actually, the next session is from my colleague Yiling, and she worked exactly on this project and also on the previous one. So they're kind of related. So she's going to talk a lot about the details. So if you're interested into this, please look forward to the next session. So that's the optimizing cost for coupons. Next, I have email retargeting. So this one works for both activation and retention funnel, actually. And the problem here is that users, most of the time, they don't make the decision to buy something in a single session. They don't think, oh, I need a new book. I want to buy this book. And then they open the app and buy it right away, right? They would go through this kind of the circle that I talked about earlier, where they compare different options, and that may take several days, right? But then before they make the decision, sometimes life gets in between, as you know, and you don't finish the decision. Maybe you even forget about it, right? So we were, we wanted to increase the activation or the retention by getting the user back into the app, reminding them of that they were looking for a product, basically, right? Or that there's an option to get it on Mercari as well. And this is what we actually what we ended up using is a pretty standard approach that you see in a lot of e-commerce companies is email retargeting. So we would reach out to the customer outside the app, right? Where maybe with an email in this case, right? We could also do push notifications, but we decided to go with emailing first because we can have richer content with even the item recommendations in there. So we ended up having item recommendations in there based on their search behavior, actually. So this was kind of straightforward because we could use the recommendation that already happens inside the home screen and feed that into our emailing CRM system. This is one of the other projects that we were working on. Since we are nearing the end of the time here, let me just wrap up here with going forward, what kind of projects we're working on. So a lot of the stuff we worked on in the past has to do with activation and retention within the buy sphere. Basically all the products, the project that I just talked about are like that. But we also want to look at potentially acquisition and referral, and then also listing and buying behaviors and how we can increase that. So that's some things we are researching this quarter and probably going to work in the future. So for us, very exciting to kind of expand the funnels that we are working on. And that's already the end, yeah. So I hope that, like I said, that maybe this was inspiring to you, that some of the projects, something you want to do in your current company, maybe similar to something you work on. Or if you're interested more, feel free to contact me on LinkedIn. So you can just search for my name. I'm happy to connect there and talk more about, yeah, data science and marketing or anything else as well. So yeah, I think with that, we could go into Q&A if there are any questions. I'm going to open that on my side as well. But yeah, feel free to use the Q&A feature to ask anything if you have questions.
Yeah, thank you for the presentation. And yeah, the scheduled time is by 35, so we can have the Q&A last time or in the closing time. So let's skip the Q&A this time. And still we won't have the QA from you. So please, if you have any question for this presentation, please push the button of the QA and please add any comments. What is the anything fine? Yeah. So we can answer the question at the end of the presentation. By the way, thank you for the presentation, Lunat. Yeah, it's very interesting to me also.
Yeah, great. Thank you everyone for listening. I saw Andre just commented that he's in the last stage of the funnel, so that's very good. So,
it's very good thing for us. Yeah, thank you.
Okay, thank you. Looking forward to the questions at the very end. So,
yeah.
Bye bye. Yeah.
And 次の発表に行く前に、皆さんご存知かもしれないんですけれど、これ、同時通訳やっておりまして、もし英語ではなくて日本語で聞きたい方がいらっしゃいましたら、下の通訳ボタンを押していただいて、日本語を選択していただければと思います。If you want to listen in English, you can choose your language by the interpretation link. So please push the button of the interpretation later. さあ、それではちょっと早速始めていきましょうか。Sorry, let's start the next presentation. Next time will be the Eileen. Could you share your screen and start your presentation?
Sure. Yeah, let me share my screen.
Okay, yeah.
My screen?
Please start. Yeah, I can see your screen. Yeah.
Thanks for joining. I'm Eileen from Mercari Marketing Data Science team. And today I'm going to talk about how we did the personalized campaign promotion using ML and mathematical optimization. I think I work with Leonard. He already introduced briefly about this project. I will introduce more details about this project. Yeah, first, like the brief introduction about myself. I joined Mercari in April 2019, and our team is mainly using statistics, ML, and mathematical optimization in the marketing domain. Let's move to today's agenda. I will briefly introduce what mathematical optimization is, and then I will talk about how we apply mathematical optimization in our campaign promotion. Yeah, the definition first. First, like this kind of technique, mathematical optimization, the purpose of that is to find out the best option, like among a lot of like alternatives. And the basics process could be we define the problem first, and then we use the mathematical techniques to model this problem, and then we solve the problem. And finally, we need to evaluate this solution is what we expected or what we want or not. So that's the basic steps. And I will give like two simple examples about the mathematical optimization. First one is the like the route optimization. And let's see, there's a trunk, and it needs to find the it needs to deliver goods to different stops, and like we need to find the best route for this truck. And but here the best could be the shortest distance or the shortest time or the lowest cost. So after defining what the best is for this problem, we can solve that, and we can get some optimal solution like the right side one. And the next one is the knapsack problem. Here we have a knapsack, and we have the maximum weight capacity for this knapsack. And we also have a set of items, and each item, it has the value and weight. So we need to decide like which item we need to put to this knapsack to get the maximum value. And also we have the limitation of the maximum weight the knapsack can have. So that's the two basic examples about mathematical optimization. The next section, I will introduce how we apply this technique in our campaign promotion. I will split that into 3 sections. First, I will introduce the background and also the business purpose for this campaign. And I will introduce the problem we want to solve using mathematical optimization. And the third part is the solution. The background side part. First, I think Leonard already introduced the user retention is really important to to our app. And we ran the campaign to send coupons to the users who might be churn users, but they haven't yet. And we want to know this kind of campaigns, we call that soft churn campaigns, and the impact of this campaign. And we compare that to if we don't issue any coupons to the users, and which is called the control group. So here the goal metrics of this campaign is the lift GMV, which is the GMV is the total value of the merchandise we sold in our app, and the lift GMV is the difference between the treatment group and the no coupon group. And also we have the guardrail metrics. It's we have the limited budget for this campaign. And here's the overview of the campaign we ran in last year, and we conducted 3 different experiments in October, November, and December separately. I will introduce the details later. Okay, the next section I will introduce the problem we want to solve using mathematical optimization. Come back to this soft churn campaign. In October, we started this campaign, and we sent 5 types of coupons to those soft churn users randomly, and we got the data for this. We got the result from this October campaign. Here we can see the test 1 to test 5 is the different type of coupons. And we also calculated the metrics for each type of coupons. We calculated BCR, which is the buyer conversion rate. And you can see that's the proportion of the buyers among all the target users. And also we calculate the GMV, which is the total value of the merchandise sold, and also the coupon cost. And also we have the ROI, which is the return on investment, the profit over the total coupon cost. And we calculate all the lift value for these metrics. The lift value is compared to the control group, what the lift impact is. So we can see this result. I just show the ranking here. You can see the test 1 group, it has the highest lift BCR. But you can see the lift ROI is the lowest one. And the test 5 group, it has the highest lift ROI, but the lowest lift GMV and lowest lift BCR. So we cannot easily decide which type of coupon is the best one for this campaign. Yeah, and I will like use the dummy data to explain why it's hard to decide which coupon is the best. You can see here we have like these 3 users, and we have like 3 different kinds of coupons, and we can get the GMV and the coupon cost, like if we send different types of coupon to them. That's all the data is the dummy data. And if we have the budget 1,000 yen, we can see obviously we will send all users the coupon C, because the coupon C can bring the maximum GMV from each user. So the solution will be like coupon C to all users. But what if we just have 200 yen budget? At this time, the best coupon wouldn't be coupon C anymore. You can see coupon B has the best performance. So here we will go with coupon B for the Alice and Catherine, those 2 users, and Bob, we won't send any coupons to him. That's the like solution. So we can see based on the different users might be interested in different types of coupons, and also our budget is limited. So based on those 2 things, we'd like to get the solution using mathematical optimization. Our problem here is how can we get the global optimal solution? It could be the maximum GMV, and considering the limited resources, it could be budget or other resources we have. Let's move to the solution we did, and also how we use mathematical optimization to solve this problem. We conducted 2 different experiments in November and December. I will explain that one by one. In November, we tried the segmentation-based mathematical optimization and used this to decide the coupon distribution. Here you can see the segmentation here means we segment the users based on the attributes or behavior they have. It could be age or purchase frequency and etc. those attributes. And like the problem we plan to solve, it's like this. We have different segments and we have different coupons, and we know the different segments might have different lift GMV and coupon cost using different coupons. So if we want to maximize the GMV, we need to find some solution like this, like the what the segmentation and also the which coupon we need to send to this segment, and what the proportion will be. So it's our question here. And if we want to use mathematical optimization to solve that, we need to define the problem and formulate first. So here's the problem definition. We need to decide what kind of coupon we will send to these different segments. And our goal is to maximize the lift GMV, and also we have the limitation of the budget coupon cost. So, and then we will formulate the problem. So we will formulate the objective we have and the constraint we have. You can see here. And also Xij here is really important. That's the, that shows the proportion of coupon J for segment I. So this one is what we need to get from this problem. So we call that decision variables. Here is the offline. Like after formulate the problem, we solve the problem, and we did some offline valuation for this campaign, and we used October data to evaluate that. You can see like this graph. The x-axis is the coupon cost per user. Under different coupon cost, we like apply the mathematical optimization to get the optimal solution. And you can see here, we can see if the coupon cost is getting higher and the GMV is also getting higher, that's the red line. And the blue line shows if we have the higher coupon cost, the ROI is getting lower. So that's what we got from this offline evaluation, and we applying this evaluation result to conduct the online experiment. We just chose one solution from this based on the budget we set. Here's the online experiment settings. We split users randomly into optimization group, random group, and no coupon group. In the optimization group, we decide a solution based on the mathematical optimization result. And random group is just randomly distribute coupons. It's just for A/B testing. It's similar to the October one we did. And also we have no coupon group. Here's the online experiment result. Here we just compare the random group and optimization group to get the different metrics, what the improvement is. We can see here the coupon cost is a little bit lower than the random group. It's almost the same, but we get the higher lift GMV. Remember before I mentioned the one intuitive conclusion we got is if the coupon cost is higher, the GMV lift GMV will be higher. But here the coupon cost is lower, but the lift GMV is getting higher. So which means the optimization group is better than the random group. And also the lift ROI is really good compared to the random group. Furtherly, we did another experiment in December. We tried to use the user individual apply value and mathematical optimization to send the personalized coupon to users. Here is the explanation, the difference between November one and December one. In November one, we can see we have the different segments, and we calculated the lift GMV for each coupon for each segments. And in December, we changed that to we have the different users, and we get the features for different users, and we can use the ML model to predict the individual lift GMV for each users. So which means we can use this one to get the optimal solution. Each user might be assigned to different groups. Because the problem formulation and also the definition is much similar, and offline evaluation is much similar to November one. So I just skip these details. Here I just show the online experiment result. Compared to the random group, it's same to the November one. We set up the random group and the optimization group. You can see the coupon cost is higher than random group. That's because the budget we set for December campaign is higher than the November one. And also, but under the higher coupon cost, we get the higher lift ROI. The previous graph shows if we use the higher coupon cost, usually the lift ROI will getting decreased. So this result also can show the random group, the optimization group is better than the random group. So yeah, that's the all the experiment we conducted for software campaign. Here's the summary for these two solutions we applied. In November, we just used the historical data for each segment, and we apply linear programming to decide each segment what the coupon we need to send to users. And in December, we used the ML model to predict the uplift value for each user. And we apply integer programming to decide each user what the best coupon is for each user. Okay, I think that's the main thing I want to share today. Here's the summary of this presentation. As we saw, we used if we use the mathematical optimization, we can get the optimal solution. Given the constraints we have. And in the coupon distribution or the campaign promotion, we apply this method to optimize the GMV and also adjust the solution based on the budget we had for each month. In November, we tried a segmentation-based way and also we conducted offline evaluation and online experiments. In December, we used predict the GMV for each user to get the optimal solution. And that's the work we did before. And in the future, we will keep working on this kind of topic. And about the campaign promotions, we will improve the model we used for the GMV prediction. And also we will consider the long-term thing, not only the short-term GMV. And we will automate the campaign settings using this mathematical optimization technique and to control the budget to achieve the cost management. And regarding the mathematical optimization, we found the result, it could be, sometimes it's not that stable. So we will try making the optimization result more stable. One thing we might try is the robust optimization. And besides this campaign promotions, we found that there are some other use cases we can use for example, the web page widget frequency optimization. This one, we will be working on this in the near future. Yeah, that's all the thing I want to share today. If you're interested in the topic I shared, or if you're interested in the work in marketing, data science, or mathematical optimization, you can welcome to contact us, join us. Yeah, I attached my LinkedIn link here. You can search Yiling. Maybe you cannot find me, but maybe Yiling Mercari, you can find me. Yeah. That's it. And here is all the metrics definitions, and I already explained that before. Yeah, that's it.
Yeah, thank you for the presentation. Yeah. Can you hear me? Maybe?
Yeah, I can hear you. Yeah.
Yes, we have several questions, and the time is limited. We can pick up the one question now, and later at the end we can answer all the questions later. Yeah.
Okay.
The first one will be you said that first using customer segmentation and later machine learning. You said maybe when you explain the phasing of your experiment, right?
Yeah, I think it's in November we just tried the customer segmentation, and in December we apply machine learning. Yeah.
Yeah, and the audience want to know the meaning. So it means that at first you will try to make the segmentation for the customers, and later you will send the promotion. At first you will create a segmentation not only by the machine learning but by human.
Yeah, the segmentation itself, it's not machine learning. It's just we pick up different attributes from users, something common could be the last purchase the user did, or the frequency of purchase, or age, those segmentations, and we try using those segmentation to do the mathematical optimization. Yeah, that's not machine learning. And in December, we replaced this part. We used the machine learning to replace the customer segmentation and do the optimization again. That's two different experiments.
Okay, I understand. Maybe, yeah, also the listener can understand it. Thank you for answering. And we also have the two questions, but those are written in English, so you can answer by text and explain it later at the end. Yeah. Yeah,
Thanks.
but yeah, thank you for good, very cool presentation. Yeah,
I will stop sharing. Thanks.
yeah, thank
Yeah.
you. So next time will be the Prashant and Karis. Yeah, could you share your screen and start your presentation?
Yes.
Thank
Sure.
you.
Go ahead. Okay,
Yeah, I
let's
can see
start.
your screen. Yeah.
Oh yeah. Okay, let's start. Hello everyone. Thank you for joining this talk, and staying on this talk is going to be the final 20 minutes. If you could get your attention. First of all, let us introduce ourselves. My name is Kengo. I joined Mercari in October 2020 as a software engineer. My background is in econometrics and machine learning, and in my master's degree, I did research on embeddings.
Hello everyone, I'm Prashant. I'm a machine learning engineer here at Mercari as well. Applied machine learning is my favorite field and I love machine learning. However, I care about the problems that it allows me to solve even more. I joined Mercari back in 2019. Careless, and I work in the CRE team, and I will talk more about our team in the later sections. So today we'll be discussing about use of machine learning to improve the customer support experience. At the end of this presentation, we will have a Q&A time and you can freely ask questions. If there are some questions that you do not want to ask publicly, feel free to reach out to me. All right. So we will cover 4 topics in this presentation. I will talk about what our team does and the projects we work on. Then Kengo will discuss converting a business problem into a machine learning problem. We'll also share an example machine learning experiment. Then I will come back again to discuss how we build machine learning services here at Mercari. After that, Kengo will share the future goals of our team. And finally, we'll have Q&A time. So let's get started. Right, let's start with our team. So as much as we try to provide a great customer experience, our customers sometimes face some issues. They contact us by sending their inquiries. We have customer support agents here who help customers resolve their issues. And quick resolution of customer issues is our priority. So what happens after we receive an inquiry? Many things happen behind the scenes before the customer support agent sends a response. Our team figures out which of these background tasks we can improve using machine learning. Then we build models for these tasks, and then we run A/B tests to validate if we actually improved upon the existing solution or not. Making these improvements using machine learning allows us to achieve our main objective, which is providing quick resolution to customer inquiries. So let me give some specific examples of the projects we work on that helps in achieving our objective. Some of the inquiries that is sent to us by our customers are pretty common, and a simple reply can solve them. We detect these kinds of inquiries using machine learning and send an automatic reply to such inquiries. Another project we work on assists customer support agents. There are many options for responses from which the customer support agent has to pick the correct one. We help them find the correct response they should use. Our customer support agents also have different skills. Each agent can help in solving different types of customer problems. When we receive an inquiry, we must decide which inquiry should be routed to which agent. If the inquiry is routed to the correct agent, it can be solved quickly. We already have an existing solution for this. However, we want to improve upon the solution using machine learning. We have recently started to work on this project. So those were the examples of some projects we are working in our team. In the next section, Kengo will talk about some specific examples of tasks we do.
Thank you, Prashant. In this section, I will talk about how we formulate the machine learning programs and how we run experiments in the domain of natural language processing. Next slide, please. Okay, first of all, let's think about how customer inquiries look like. If you use Mercari, you might be familiar with this process, but first you choose what kind of categories you want to inquire on. The first row says registration and login. The second one is about payment, shipment, And on the right, this is a feature that we are releasing as of now. And you can sort of have this modern messaging UI where you can have the inquiries that you wrote on the right, and from the left, you see responses from the CS agent or customer support agents. Next slide, please. Okay, but how does an inquiry look like in terms of data?
あれ止まっちゃったかな So could you explain the current part instead of him?
Yeah.
Thank you.
Yeah, no problem. So what does an inquiry look like? So there are some metadata for our inquiry. So what is the category for the inquiry? There are some user metadata who is making the inquiry, and then there are item metadata which are optional. So item metadata could be the which particular item for which a user is making an inquiry, right? So there are like different kinds of solutions that we can create. So first thing could be rule-based approaches, and that is the first thing that we should always try. If we should try the simple rule-based approaches, and we can use these rule-based approaches as a baseline model when we try to build machine learning models. Next thing is the inquiry body itself. So inquiry body is a text, and this is an unstructured text. So we use natural language processing to convert these texts into vectors, and then we run some kind of our machine learning models on top of that. Sorry. Right. So next topic is how do we convert a business problem into a machine learning problem? So the main business problem that we're trying to solve is that replying to a customer inquiry takes a long time. And if you want to provide a great user experience, the reply time should be low, right? So we need to reply to the user inquiries within a certain window. And if the reply time is high, it leads to worse user experience, and the operation cost also goes high, right? So we also know that the customer support agents use some kind of pre-made templates depending on the issues. This is, we have already written some blog about it if you want to reference it. So since we already know that the response is going to be from one of the templates, so we can try to model the problem as a multi-class classification. However, there is one issue. Suppose if you have 100 different templates, all of them are not going to be used uniformly. So the use of templates depends on the kinds of inquiries we get, and the kinds of inquiry we get are not uniform. So it could maybe follow a Zipf's law. So there is always a skewed distribution of template uses. Anyway, if Carolus is back, you can let me know.
Yes, thank you, Prashant.
Okay.
Can you hear me?
Yeah.
Yes, thank you for the smooth transition back to me. Sorry, I was disconnected for a bit. Next slide, please. Right. So one of the experiments that we actually did last year was to reduce dimensions. And the problem that we had at the time was that we had a certain architecture of CNN to classify text into different templates, but the experimentation cycles were too slow. It was taking more than a day, for example. We wanted to tackle that problem. And what happens typically is that you try to tweak the architecture itself. Let's try to say, for example, trying to reduce the dimension size or like try to make it like less wide or shallow, the network itself. But what we tried to focus on was embeddings. We used to train embeddings from our own corpus, Mercari corpus, from scratch. The reason we did that was because there were some terms and out of vocabulary words that were very crucial that worked as a signal to higher performance in our models. for example, shipping methods or payment or anything that's related to Mercari ML services. Right? And this embedding used to be trained once in 300 dimensions, and it was used in multiple architecture different projects. So there was a huge room to improve on this specific embedding. Yes, if you take a step back to think about like any machine learning program, what we do is we take texts and split them into tokens, and we convert them into feature vectors, right, of n dimensions, for example.
I think he's not present again. Okay, so I can take over again and let me know when he comes back. So generally what we do is we have a predetermined range of embedding. So maybe 300 dimensional embeddings, and these embeddings are generally pre-trained on a large corpus, so something like a Wikipedia corpus. However, that does not fit our use case. So in our use case, there are certain vocabulary words that are quite specific. So maybe we could work with a smaller set of embeddings. So in our case, corpus domain is very, very specific. So which is the customer inquiries and Mercari, which has Mercari context. So yeah, so this is the experiment we ran about last year about dimensionality reduction. So originally we had a 300 dimensional embeddings, and what we did was we tried to run PC on it and try to select, try to see how much variance can, how much variance we can capture it if we use lesser number of dimensions. And in the graph, you can see the blue line. So this would be kind of a embedding where as you add a new dimension, you get more information, right? So the kind of, you can say that the information is uniformly distributed across dimensions, but generally that is not the case. So in our case, we kind of ended up with the orange curve, where as you add more dimensions, you will get the lesser marginal return in terms of variance capture, right? So we were able to capture about 80% of the variance or 80% of the information in the corpus with only about 100 dimension. So that was quite good. Right. So when we reduce our dimension size from 300 to 100, the number of trainable parameters in our model reduced by about 66%. And this happened for both during the training and inference time. And the surprising result was that in some cases, the accuracy metrics also actually improved when we used the smaller embedding size. So some of our hypothesis for this was like maybe due to larger dimension size, maybe it was the model was getting stuck in some local optima. And another benefit that we got from reducing the dimension size to 100 was that the training time was reduced by 50%. So this results in the training time is cut by half, so we can do experiments at a faster rate, and our iteration cycle was improved. All right. So far we talked about the projects we are working on in the customer support domain. We also saw how to convert a business problem into a machine learning problem. However, the ultimate goal of solving that machine learning problem is to satisfy the business need, right? So what do I do with my machine learning model? So suppose if I were working on a machine learning problem and I started playing around in a Jupyter notebook, and then I discovered that my machine learning model had some promising results. What do I do? What do I do with my model in the Jupyter notebook to actually solve the business problem? So we will shortly see that the writing machine learning code is actually just a small part of solving a business problem using machine learning. Okay, so how do I start solving the business problem? I start by following the first rule of machine learning. Don't use machine learning. So most likely the results produced by my model will be used by some other programs, right? So first we should ensure that other programs can talk to my program. I start by creating an API for my use case. For example, for the automatic reply project, the API will be a simple interface that takes an inquiry as input and returns a text response as output. So there are many tools in Python to build such APIs, such as Fast API and Flask. At Mercari, we use gRPC framework to build our APIs. Do note that I do not use my machine learning model that I created yet. First, I set up a server without using machine learning. I use some simple rule-based heuristics. So I want to make sure that other programs can actually talk to my servers now. When that is done, my system is up and running. Now I can add machine learning to my system. We can use solutions like TensorFlow serving, PyTorch serving, Kubeflow serving to deploy our models. In our team, we use TensorFlow serving as of now. Then I integrate the machine learning model into my already running system. So now that I have deployed my solution for the business problem, we are done, right? Not quite. How do I know that the model I created is actually providing good results? How do I know that the model is achieving the same level of accuracy or F1 score or any other metric in the production environment compared to when I built it? So the thing about machine learning is that data distribution often changes in the real world, and it can cause my model to perform worse. To solve these problems, I need to monitor the inputs and the outputs of my model. By monitoring, I can detect the drift in the input, and I can also detect the degradation in the performance from the outputs. After I set up the monitoring, am I done? No. By monitoring my model, I can figure out that the performance of my model has degraded. So we need to take some action now. We cannot just leave the degraded model alone, right? We need to retrain the model on the latest data. So do I go back to my initial Jupyter notebook to create a new model? I can. But if I need to retrain my model every week or every month, it is not very efficient or convenient. So we need an automated pipeline to retrain our models and automatically deploy them. That's where the automated data collection and automated data and model validation comes into the picture as well. So as of now, we do not have an automated pipeline for deploying models in our team, but we are working towards it. So that is the overview of how we build machine learning service here at Mercari. I hope my explanation helped you understand that to solve a business problem with machine learning, we need to build robust and reliable systems in addition to building machine learning models. So the practice of building your machine learning systems as well as operating them is ML ops. At Mercari, each team has ownership over its own services, and we highly encourage ML ops at Mercari. So far we have seen the projects our team works on, examples of some experiments, and the process of building a machine learning service. So Kengo will come back now to discuss the future goals of our team.
Thank you, Prashant. Finally, I'll conclude this presentation by talking about the future plans and objectives. Next slide, please. As Prashant said, the main business problem stays the same. Like what we want to do is to make the customer support process more efficient, and solutions do not necessarily have to be machine learning based. We can set up a simple baseline and try to improve upon it with machine learning if that's applicable, but oftentimes that's not the case, and that's okay. And we can also use different kinds of approach. We can do typical software engineering to implement new features if we think that's going to benefit the whole process in the end. And what's most important is that we measure the effect through A/B testing and tracking metrics. Being able to track different metrics visualizes and sort of quantifies so many things that we want to see. And setting up a proper A/B testing framework with experiments in sufficient data, that is very crucial to establish like what we did was actually successful and how it can be useful in the future solutions. Last slide, please. So to make that a bit more concrete, I'd like to talk about the routing optimization problem that we're trying to solve at the moment. I talked about the inquiries at first and how they are assigned to different operators. And right now, this is based on some heuristics. We pick up some keywords and try to assign it to different agents, which have different skills. And you can see in this diagram, this is what that selection process happens. So based on the case, which is an inquiry, you assign this to different agents, and we suggest different templates. Oftentimes we can also reply automatically. And this assignment process can be improved with machine learning. And you can see the overview of the whole process in this article. And this is where we need more people like skilled at machine learning and sort of think about different experiments to jump into to join our team. The final slide, please. Yeah, we can take Q&A if you have enough time. And you can sort of see that from this presentation, if you could take away that what you can expect from joining our team is that we use AI and data-driven methods to improve customer operation, which is like the biggest goal. And we do own the entire machine learning pipeline. And we also have like different platform teams to support us, right? And again, finally, as I keep saying, running A/B tests is so important, like to validate your ideas and sort of improve on the customer experience that we have.
Okay, it's almost finished, so that we can start the QA session for all the presentations, maybe.
Yeah.
Okay. Okay. So yeah, please. Also, yeah, Ely and Leonard, please join the Zoom, and then we can start the QA. And to first, I think that you already answered some question on the QA chat. So please, at first, Leonard or Ely, could you explain your question and answer those questions?
Yiling, you want to start with the first one that you replied to?
Sorry.
Or did you reply verbally already?
Let's go in order. Let's go the open one first or the answer one first. Which part we go first?
I think we can go with the answered one as well.
Yeah. Answer one, I think the first question I already answered that in my session. So maybe the second one, then you can.
Okay. Yeah. The question was from Andre. 3 questions actually. So the first one was regarding if we take like seasonal changes into the machine learning models, like Christmas or new products coming out. And the short answer is no at the moment. We don't take that into account. I think there's like a practical reason is that it's a lot easier to account for that manually right now for us. So marketing actually, so these seasons are important. So they, for Christmas or Osoji, like the cleaning season and others, they would make manual campaigns. They would come up with special campaigns, like special creatives and landing pages to that we then show, for example, on top of the home screen in a banner, or let the user know via emails or push notifications, in-app notifications. But we have set it up in a way that the marketing team can manage that manually by themselves, so they don't rely on developers or back and front end teams. So right now, also in the data science team, we don't take that into account. Yeah. If Yiling, if you want to also answer to that part, feel free. Otherwise,
like the first question I'd like to add, maybe you can finish first and I can add something.
Oh, go ahead. We're still on this question. So
okay, yeah. I think the first one, I did some analysis lately. Like also like I found something interesting about this. I was also like proposal some ideas about seasonal listing. I think that's a really good point, good idea, and we don't have those things, but we also want to try this kind of ideas. Yeah. Also iPhone, iPad, I found something interesting about those like transactions and items. Yeah. Thanks for asking this one.
The second question was regarding if instead of sending random coupons, if you could let them pick the coupons. That's very interesting because we were thinking similar things, like creating different options for coupons and say, okay, you get 10% off if you buy an item above X yen and 5% off if it's above Y yen value. It's actually something we're still considering, but I think originally why we chose just random, because it's a lot easier to do for us independently in the data science team. Because if we want to have the option for the user to pick coupons, we would need to design some front end as well. And that would involve more work and other teams. So as like a small start, we just went with random coupons to collect data. And the third question, yeah, that's interesting. Like I replied, the question was if we are going to have a localized version or English version of Mercari. I can't comment on any concrete plans, but we are always looking at like our potential customer base that we are missing, right? English speakers in Japan, but also outside of Japan. It's an interesting market. So I posted a link for an example of how we are selling to Chinese customer actually. So we're allowing Chinese customers on a different platform to buy things from Mercari indirectly. So these are like areas that we explore as well.
We can also go through maybe other question. For example, the next one will be answered by Aileen.
Yeah, this part. First, I'd like to explain. In December, we combined the machine learning and mathematical optimization together. And in November, we tried a customer segmentation plus mathematical optimization. So, and this part, because of the limitation of the budget and sample size, we couldn't do the online experiments, like to compare those two parts directly, but we did the offline evaluation, and the ML plus mathematical optimization is a little bit better than segmentation based thing. And also this part, we found the GMV prediction is a hard topic in this project. So this quarter, we will continue doing this to improve the model part to see if we can get a better result. Yeah, that's this question, I think. Did I answer the question? If there's like some question further, you can ask later.
Oh, thank you. Also, all the answer is, yeah, you already answered all the question, and I want to pick up one question from the attendee form, and basically I would ask those questions to the CRM marketing, and also the customer support services, and especially some people are very interested in how do we evaluate the effectiveness of the improvement. So it already explained in the session, but could you answer more detailing? You can explain how do you do the A/B testing, or do you have any worries or best practices to do the evaluation? First, yeah, you can answer Amy, maybe, yeah.
Sorry. Like you asked how we conducted the A/B test.
A/B test, yeah. And do you have any issues or best practices to do the A/B testing?
Yeah, I think we always do the offline evaluation first, and we have some strategies to check the business metrics for the offline evaluation first. And A/B testing, I think this like there's one person, Paul, mentioned like different time, it could be different. And so the A/B test, we need to promise that we run at the same time, and we randomly sample the users into the different groups. And also one more thing is the sample size for each group. We met a small issue before is if the sample size is not big enough, if we want to check the impact, especially the GMV, it's quite various in different groups. So the standard deviation is quite big. In that case, we need to check the sample size before the A/B test, what we need to decide how long we conduct the A/B test and how much budget we need for each user, those things. So yeah, that's the some experience I got.
Yeah, thank you for explanation. By the way, do you have any best practices or I don't know difficulty to do the A/B testing on the customer service side, Prashant or Karis?
So one of the most important thing about A/B test is you should define the metrics, or you should define the outcomes that you are looking for before you start the experiment. You should not change your experiment after you see some initial results or something. So that is, kind of like cheating. So define the metrics and define the outcomes that you define the possible scenarios that can happen before running the experiment. And second important thing is, as Elaine was talking about, you need to know about sample size, and to know the sample size, you need to know what kind of effect you want to detect. How much percentage of change are you looking for? So that is called minimum detectable effect. So you should have some kind of idea about how much change your new feature or your modified feature can bring. So try to estimate that. It's always difficult, but try to estimate that somehow, and after that you can work out how much sample you need in each variant.
Thank you for answering. How
If
about Karis?
Yeah, if I could add one more thing, is to try to eliminate all possibilities of the two sort of like metrics, KPIs being different between two groups. And one thing you can do is to run first like AA testing, because two groups, if you randomly split them, the results could still be different, right? That basically sort of gives you an idea as to like what kind of distribution a given metric has, right? For example, like how long it takes for customer support agents to reply. Those could like easily come from random variation in two groups. But to make sure like what you implemented like in the treatment group is actually affecting like the desired KPIs, you can first run AA test and then switch to AB test, for example.
Yeah, thank you for answering. I hope it will helpful for the listeners. And yeah, time is limited. And this will be the last question in this Q&A session. And we have the new question, Elaine, to clarify on my question. When calculating CV also, this is the last question. Yeah, I think Leonard's slide mentioned doing to prevent customers from churning against a CVR. I was wondering how that CVR conversion would be defined. Can you answer the question?
Yeah. For in this case, conversion would be buying something on Mercari, right? So churn would also mean that someone stops buying. So the conversion rate is how many people of those targeted customers with a coupon, for example, are actually buying something with a coupon. So that's the conversion rate. So yeah, in this case, it's buying, but sometimes conversion could be listing or could be paying, right? It kind of depends on the campaign or the project. But in this case, it was buying.
So also for this conversion, you mentioned about the action, but also we will define some range of the time. For example, if someone have the buying in a month, it means the conversion or something, maybe.
Yeah. So it would have to happen within the coupon period. So again, it's a coupon has like a valid period. So it has to happen within that period.
Okay. Yeah, thank you for asking a lot of questions. And I would like I'd like to closing the this meeting, this event. So yeah, thank you for joining today's number 2 Mercari ML&Search Talk. And next time, it's still tentative plan, but it will be held around April. And we will talk about the ML and search platform, like how to learn or training the ML models, And also, we are creating a search platform in our company, so that we would like to talk about those topics. And yeah, we are looking for engineers, not only, of course, ML engineers, but also we are looking for all kinds of engineers. So that if you are interested in our company, please, Google our company and with the hiring. Yeah. Also, the last one is that if you close this Zoom, we will send you the survey, and I would like to improve the events and for the next time. And please answer your survey, and I will count it for the next event. Yeah, that's all, kana. Yeah, maybe that's all for my side. And thank you for joining this event. And we are very happy to share our status to you. Yeah, let's keep in touch with you. Yeah, thank you. Bye.
Bye.